Last thing that I want to explain is density. Okay, we're going to be doing density on maps, and what we get by density is we take the number of individual observations and then we divide by some larger number, which is usually population or area. A figure that we use a lot is population density, right? That's important. Population density. What does that mean? It takes into account the people who live there, but it also takes into account the size of the place, right? So the assumption usually is, which is always incorrect, is that people, things, phenomena are equally distributed over geographic space, but that's just not the case. Some things are more concentrated in some areas more than others, so we come up with a density, right? So for example, one of my favorite statistics is that I think like Tokyo and Canada have near the same amount of people, but Tokyo is a lot smaller in geographic size than Canada, right? So Tokyo is more dense. It has more people in the same or smaller geographic area, right? They're using gas, liquid, solid, but this is less dense and this is more dense. Cities are more dense, more people in a smaller geographic area. The rural areas are less dense, less people in a geographic area. We can also talk about, let's say, sometimes I do this thing, pollution per person, right? So if we're talking about a particular state, we might want to know how many people are in there. And then based on how much pollution they have, we say they have more pollution per person. We divide the total number of pollution by the population. Or we could talk about COVID cases. Of course, California and Pennsylvania, New York and Texas and Florida are going to have more COVID cases. Why? Because there's more people there, right? Shouldn't send us into hysteria. That makes sense. If a state like Wyoming had the most COVID cases, then that would really be crazy because they definitely don't have the most population. So less people per area, less dense. More people per area, more dense.